Hi folks, I'm Mark Rutten. Welcome back to Nomad Boat Building, and we are back on the 2.4 meter project, and we are ready to start planking. But in order to do that, we need planking. So we had decided to make our planking for this boat double diagonal, and that means we have two layers of planking. One's running forward at a 45-degree angle to the center line or to plumb, and the other one's running 45 degrees aft. So they're running at 90 degrees to each other, or very close to that. Now we decided to make the inner layer yellow cedar and the outer layer sapele mahogany. So forget how this model looks right now. Ignore this mahogany layer running like this. We're going to have the yellow cedar layer running aft and the sapele layer running forward. Now we chose those woods for a very specific reason. Yellow cedar is very rot resistant. It's relatively lightweight relative to its strength, and it's highly workable. So that means I can shape it quite easily, and once it's glued onto the boat, I can fare it off really easily. And that's one of the key things with this particular construction. We really don't have planking that fares itself out like you would with lap strike planking, for instance. So we need to be very careful about that. So that is why we put the effort into the mold, trying to get the mold nice and fair, but we also have to put that same effort into the planking itself. So we're going to do our best to get this planking really forming to that mold very tightly. And after the first layer is attached and glued up, then we're going to fare it off. We're going to go through the process of sanding it down, planing it down, getting rid of any humps and hollows, and try and make it super smooth so that when we put the next layer on, it's going to go on nice and fairly as well. And of course, we got another fairing process after that. The sapele mahogany, we like that because it's got great color, looks beautiful under varnish, and it's got good rot resistance, and it's a nice hard finish too. It's a nice hard wood so that we don't have to worry about dings and scrapes quite as much as we would with yellow cedar. Now yellow cedar, if you do scrape it or ding it, it kind of shows up a bit badly, you know, whereas the mahogany has got so much ribbon and figure and stuff going on that you're really not going to notice very much. And so it's going to clean up very nicely. And worst case scenario is if you had to fill a gouge with a bit of putty or something like that, as long as you sort of match the color to the darker range, it's going to kind of disappear. Whereas virtually impossible to try and get any sort of putty or filler to match the yellow cedar. In fact, even glue lines on the yellow cedar are going to show up quite badly because it's very difficult to get anything close to that color. So today we're going to start milling up some planking, and we'll explore some of the techniques I'm going to use for that. Now let's get down to work. Now I've got a good solid day of milling ahead of me in order to get all the planking stock prepared for our project. The decision about what to use started quite some time back when the designer Hasse Malmsten suggested we make up some test panels. That's to determine what kind of scantlings we'd be using for our hull. According to the international 2.4 meter rules, our hull and deck materials need to weigh a minimum of 3.6 kilograms per square meter. That's the same as 334 grams per square foot. So that's our target weight. We can't be under that, but we don't want to go too much over that. We made up quite a few different test panels using different combinations of wood species, thickness, with and without fiberglass, all trying to find a panel that would fit within our weight range. Okay, here's our test panel. Now, unfortunately, our first round of samples was way off the mark, and part of that is because I'm used to building more worky type boats, and my thoughts about how heavy something needs to be is a little bit out of proportion with what you need to do in order to create something that's competitive for racing. So it was back to the drawing board, make up more samples, and keep exploring. So this is our final sample: 3 millimeters yellow cedar, 2 millimeters sapele, 81.9 grams, so that's 82 grams. So we get 328 grams, which falls within our ballpark figure. It's interesting to go from sample number 1, where we were thinking 1/8 of an inch of sapele and 1/4 inch of yellow cedar, way over the mark. Even red cedar and sapele with 1/4 inch and 1/8 of an inch was way over the mark. And we're closing in on it a bit better with the 1/8 inch Sapele, 1/8 inch yellow cedar with glass. This one's, I think this is a 6-ounce glass on there. And then we start dialing it back. Now I just go down to red cedar, yellow cedar with 4 and 6-ounce glass. Thinking we would go with just yellow cedar, yellow cedar. Well, you know, the thing about this is very hard to get yellow cedar to finish out well. Things like glue lines will show up like a sore thumb. If you don't fair it out really nicely and sand it to a certain level of finish, like scratches will start to show up really easily once you start putting finishes on there. And whereas Sapele is, you know, it hides a lot of evils. It's great that way. And it's a harder finish, so I decided to go with no glass, just yellow cedar inside, Sapele outside. That's giving us a nice combination of hardness, toughness, rot resistance, and this is going to finish out really nicely. That'll probably end up getting painted on the inside maybe, but we'll see how it looks when we actually get down to it. I was thinking about getting plastic staples. I don't know if I really need them. I might be able to just get away with steel, which makes them removable and gives me a much smaller hole, so I think steel might work a bit better actually. And of course our fallback position is just going red cedar, glassed inside and out. But that means it's a lot of glass, and I don't know. Now we just have a strip-built boat. This doesn't seem like it's nearly as interesting. Of course, with the strip-built boat, you're always worried about anytime you have a penetration through that fiberglass. If you don't seal it out well, it is just a recipe for mayhem going on underneath. Whereas our, you know, no glass hull right here with two good rot-resistant woods, drill a hole through there, and it's not that big a deal. You know, slap a little finish in and it's fine.
I would love to have been able to order up the veneers for this project pre-cut. The reality is that we don't really need that many of them, and so to have it custom cut by someone probably would have been prohibitively expensive, and I prefer having the control of exactly what wood goes into this boat rather than leave it up to chance. My first step is to create some billets that are a little under 3 inches thick so that I can resaw my veneers on the table saw, and to orient the grain properly. We want vertical grain, which will maximize dimensional stability and strength.
So one little detail I'll point out is with all of my stock here, I've got it basically broken down into little billets, and I've given myself a little red crayon mark at one end on one side. And that way, when I've done all of my cutting, I can reorient all of these sticks to get the same orientation. So when I put them on the boat, I can orient them in the same manner. And if I'm doing any cutting with planes and things like that, the grain orientation is going to stay the same on me, which is fairly important. To that end, I'm also bundling all of my little sticks together so that each one of these gets a separate bundle when I'm done. Now I started out using a smaller 7 1/4 inch table saw blade on here, trying to get as thin a kerf as possible. But what I was finding is with these lighter blades, sometimes they'll tend to sort of want to bind a little bit or warp as they move through the material, especially if you're doing a deep cut. Because I have to rip and then flip, you get sort of this magnification of any sort of deviation. And so what happens is sometimes you get this little step in your material, and the biggest issue is not so much the little step that gets created, it is if it starts to get uneven too much, and then I need to run the stock through the thickness planer in order to flatten it back out to keep going. And I was finding after about 3 pieces I was having to do that, so it's a bit of a time killer, plus the idea that you have to keep flipping the stock over to do 2 passes in order to get 1 piece of material out. I decided to just switch to a larger blade. It definitely eats up more wood. With the heavier blade, I get the same number of boards out, and my last piece of what is otherwise scrap here, like this one, doesn't exist. It turns into sawdust, but it nets out to the exact same number of veneers, which is 7 veneers for each one of these little pieces of material. In the end, it's more economical for me to use this larger blade than it is to work with a smaller blade. So I've got a vacuum fence set up on my table saw here, and the idea behind this is it helps to control these thin veneers as you push them through. So if I just turn it on, as they run through the blade, they get sucked to this fence, and as a result they don't want to flop down into the blade. It's amazing how much suction there is once you've closed off these slots. If I bring this right along here, the moment it gets closed up, you can really feel how much pressure is on this thing. I've even drilled holes in the top to sort of mitigate that, because otherwise the vacuum overloads. And just even, like, it's amazing how much more pressure I need to push it just through that stretch where it's completely closed off.
One more little setup detail. I created a splitter by using a drill bit sized to match the kerf of the table saw blade.
So for now I'm just going to mask up, get all the fans going in here, get the dust extractor going, and I'm just going to start banging out wood, and I'll be at this for a little while, I'll tell you that much.
I'd like to thank all of my followers on Patreon, whose financial support makes these videos possible. For as little as $1 per month, you can help support this channel. If you'd like to become a patron, please follow the link in the description or up in the corner. If that's not possible for you, I understand that. You can also subscribe, like, and share these videos, and that helps me out too.
Okay, that's it for this video, folks. I hope you enjoyed that. Now, I think the takeaway here is that processing materials for a project isn't just a matter of shoving things through a saw. It does take some planning, some thought. How do I make the best use of my materials and the best use of my time? What is the most cost-effective, efficient way to take this big thing and reduce it into a bunch of little things without a lot of waste? I think we did pretty good with this, and I don't think if I had ordered up materials from someone else who'd made it, I suspect that there'd be a whole lot more material lying on the ground than there was when I did it, because I know I was pretty darn careful, and really the only waste from doing this little particular job was a little bit of sawdust. So that's it for today. Come back next time and we're going to start planking this boat, and it will get a whole lot more interesting than today's video was, I assure you. Ciao for now, folks.